Hey, what's up? It's Friday, April 2nd, 2021. Yep, April Fool's passed, and that's why I didn't post a video. That's exactly the reason why. Fooled ya. I still am making videos. I know for all of you who are watching and who watch me intently, glued to the screen, you're probably really upset. Probably not, and that makes me cry. Anyway, yeah, so today I wanted to do, this Friday night, I wanted to work on it's a problem type that I haven't worked on so far in my videos, and that would be a sorting problem. I've used sorting before, but I don't think I've ever done a video just where the primary point of the algo was to sort some input, and produce some output. So I just picked this easy one called titled "Sort Array by Increasing Frequency" 1636 on Leetcode. I thought this is an interesting problem because it looks like one of those problems where you want to, it's not, you don't necessarily sort using the standard sort criteria. There's going to be a bit of a trick to the actual sort. And so let me go into the problem, but if you like my videos, let me just let you know beforehand, if you like my videos, please like, subscribe, and don't forget to comment. The more comments and interaction I get with these videos, the more I get motivated to keep producing more quality content, or what I believe is quality content. All right, well, so let's go. The gist of the problem is, I shall read it. Given an array of integers nums, sort the array in increasing order based on the frequency of the values. If multiple values have the same frequency, sort them in decreasing order. Return the sorted array. So the example, so that sounds a little tricky right off the bat, right? So the example is you have an array nums, and nums is 1, 1, 2, 2, 2, 3. So that looks already sorted in numerical order, but you actually have to sort the array in a different order based on just total frequency of occurrences of each of the individual items. So right off the bat, that makes me think of using a hash map, okay, to count, because whenever I hear frequency, I think of using a hash map or some sort of count holding data structure, right? And so that's either a hash map or an array. So I feel today that I want to use a hash map. And the second example also shows you another similar sorting where the sorting occurs by frequency. But also note that the second condition is that if the frequencies of two elements are the same, then you have to sort in descending order. So that means that the occurrence of 2 and 3 are both 2. So 3 would come first because 3 then 2 is descending order, not 2 then 3. So you can't just arbitrarily leave the sort from the previous step in whatever order that it just naturally fell to. You have to actually take it a bit further. So let's try to get this ball rolling. So it's called frequency sort. So the first thing I'm going to do, and you know what, I want to try to get this done pretty quick and clearly, so I'm going to create a list to hold my items. So like, it's easier for me to work with collections. I know there's all sorts of Java tricks to do everything in the actual array, but in my mind, collections are more intuitive. Though it probably slows things down a bit to do that, but you know, I want to convey the logic of what I'm doing. Okay, so what I'm gonna do, I'm just populating that new collection, right? Okay, and so as I said, I want a frequency map of some kind, right? So what I'm gonna do is I'm going to actually create a frequency map, but I'm gonna keep it outside of the function because I don't want to. I have a reason for this. So I'm not initializing the map every single time, right? It's just one instance of it when the function gets invoked. Okay, so what I want to do is now I want to actually perform the sorting, or well, frequency counting actually. So let's, before the sorting, we want to do the frequencies counting. So in this same loop, I can put the frequency of my elements into the map, right? So any new element that I add gets is checked by this get or default method for its existence, and if it's not there, it'll return a 0, and then you add 1 because you've essentially found a new occurrence of the element and that you're populating it for the first time. So at this point, I'm going to I'm going to sort my array, and I will get to this in a second, what the details here are, but this is, I'm going to first define something called a sorter. I'll get to the definition of that later, but let's say that this sorts my array. Then finally, for int I equals 0, I less than num list.size I plus plus, and then I'm just refilling that array. Num list.get I. I'm getting the I. I'm just populating the original array, and there you go. So I'm basically, what I'm doing, counting my frequencies of occurrences of elements, sorting by the frequency with this sorter that I have yet to define, and then just redefining, or redefining the old array's indices to the new sorted array. Okay, so now what's happening with this sorter here? What's going on? So I'm going to define this actually outside as well of the function, the entry point function. I'm going to create a new class called sorter, implement, and I guess I could have done this with an anonymous function, but I feel like doing this way for now. Comparator, okay. Custom sorting in Java pretty much always gets a comparator utilized to do it. And the comparator is presumably under the hood doing the actual sorting the fastest it can, which is some version of an integer sort algorithm, which would be probably a quick sort or a, conditional insertion sort, depending on the size of the array. Whatever's faster, right? But that's under the hood. That we don't have to worry about. Now, what do we want to do? We want to sort based on frequency. So, but also, not only based on frequency, we want to sort on the second condition, based on frequency being equal, we want to sort on the actual value in descending order. So let's start with the frequency. Freqmap.get a minus, and this comparator is a very useful gizmo here, right? Useful interface, because it lets you control all the dynamics of the sorter, right? So anyone new to Java should really appreciate this thing here. Okay, so so what I did here is if the frequency map at element A minus the frequency map of element B is equal to 0, if they're equal, right, return B minus A. So that's my second condition, right? That means that if the two things are equal, return them in descending order. So descending order would be the second or the first, right? The greater would be B, and the lesser would be A. So whatever happens to be greater would get returned first in the list. And then if they're unequal, then the first condition holds. Freqmap get A minus freqmap.get B. So based on frequency, the elements will return in ascending order based on frequency, not descending. Descending is for value, if in case of a frequency that they're equal. So this is how you can impose two sorting conditions on a single in a single sorting mechanic. It's very useful if you want to sort by different parameters on the same array in the same sorting cycle. So let's try running this. I'm sure there's stuff wrong. Sure, for expected. What is going on here? Yeah, implements. Right. If I spell implements wrong, Java should yell at me about the spelling. Line 20, numList equals nums. Okay, always an S or something here and there. And there you go, accepted. Now let's try running this bad boy against all the test cases. And there you go, accepted. Kind of memory hefty, and that's probably because I did all these, extra memory things here, but faster than 55%. That's good enough for me. So, yeah, I'll take it. And there's faster ways to do it probably with less moving things around, but you know what, this works, and so I think the logic was clear. So I'll keep it at that. If you like this video, like, subscribe, and do all that good stuff that I reminded you of in the beginning, and I'll see you later. Oh, you know what? I forgot one thing. Time complexity. Yes. I was too quick to jump the gun and bounce before I could just... Let's look at the time complexity. The sort is log n time. That's really what's taking up all the cycles, right? Everything else is on a linear order based on the number of elements. So the sort is the long pole, and we shall call that n log n. Okay, O of n log n. So that's the sort complexity. Okay, it's very straightforward. All right, and that's it for real. See you later.